This is the basics of how to graph a quadratic function. The parent function for a quadratic is y equals x squared. Okay. When we add in our parameter shifts, it's y equals a, and then parentheses you have x minus h in close parentheses squared plus k. Okay. For a quadratic function, the parent function is graphed. I'll graph that in blue. You start at the origin, 0, 0. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. You do the same thing, but you go to the left. When x is negative 1, y is 1. When x is negative 2, y is 4. When x is negative 3, y is 9. This is your parent function for a quadratic. Okay, we know that, we learned in Algebra 2, that you have a horizontal shift and a vertical shift. So your x minus h, the inside there, is going to determine if your shift is going to be horizontal to the left or to the right. If it's x minus h, it's going to go to the right, whatever h is. And if it's x plus h, it's going to go to the left, whatever h is. Okay. Also, you have a vertical shift up and down. If it's plus k, then we know it's going to be up whatever k is. If it's minus k, we know it's going to be down whatever k is. Okay? So, if I were to take this graph, and I were to shift it left 3 and down 4, the equation of my new graph would be y equals, and then I have x plus 4, sorry, it's x plus 3 in parentheses squared minus 4. Okay, so there's a horizontal shift to the left 3, so notice inside is positive, and a vertical shift of negative 4, so the outside is negative. Okay, so with that, with my parent function there being shifted, if we go back to the origin, here. Okay, that's the horizontal shift. So the h is the left to right, the k is the up and down. Now we have a vertical stretch or vertical compression having to do with the a value. So the a value is what's going to determine whether it's a vertical stretch or vertical compression. So if a is greater than 1, then we say it stretches. If a is less than 1 but greater than 0, then we say it compresses. So, here's how that change affects the graph. So, for example, if I have y equals x squared, okay, if you notice the pattern, your vertex is going to be your h comma k. Okay, your distance up to your next point is 1, and then your distance over ends up being the reciprocal of b, which we'll talk about here in a second. And then your distance up is 3, your distance over is the reciprocal of b, and then your up is 5, your over is the reciprocal of b, and so on. Okay, so that is the change vertically from the parent function. Okay, the a value affects the graph. For example, if I had y equals 2x squared, the way that it would affect the shift here. Okay, so the way that it would affect this guy, the way that it would affect the shift. Okay, so that's what we're going to look at how it affects this shift. Because the a value is 2. A value is 2. Okay, it's going to multiply the 1 2 times 1, 2 times 3, and 2 times 5. Okay, so if I were to graph that, we would start at the origin, and we would go up 2 over 1, because 2 times 1 is 2, up 6 over 1, because 2 times 3 is 6. And then if I could, I would go up 2 times 5, which is 10. I would do the same thing going to the left because it is symmetrical, and that would be my graph. So this would be my graph of 2x squared. Y equals 2x squared. Okay. If I had y equals 3x squared. Okay. So instead of multiplying the 135 by 2, I would now multiply them by 3. So this would be 3 times 1, 3 times 3, 3 times 5. 3 times 1 is 3, 3 times 3 is 9, and 3 times 5 is 15. So I would start here at the origin, and I would go up 3 over 1. And then the next one, instead of going up 6, 3 times 3 is 9, so I'd go up 9 over 1. And then I'd be able to connect my dots. Okay. So regardless of where the vertex is your h comma k. After that, that's going to, then I would just do the pattern going up. Now the reciprocal of b is something that we added since we entered pre-calculus. So let's discuss the reciprocal of b. So you have a general form of the equation as y equals 3 parentheses 1 half close parentheses x plus 4 close parentheses squared minus 6. We see that it's quadratic because of the square. The vertex will be at -4, -6. Okay, so on the graph we have a point at -4, -6. The vertical is being changed by 3. So remember, the parent function is h comma k. Okay, and then if I take my little stairs to follow my pattern, this is 1, 3, 5. The up is changed by a. In this case, a is 3. A is 3. So that's how it's changed. So it's going to be 3 times 1, 3 times 3, and 3 times 5. Okay, the over is going to be the reciprocal of b. The reciprocal of b in this case is the 1 half. Okay, the reciprocal of 1 half is 2. So the over here is going to be the reciprocal of this number. So it's going to be over 2 every time. Okay, so from my vertex, to graph this guy simply with, from my vertex, 3 times 1 is 3. So I would go up 3, out 2. And then 3 times 3 is 9. So I'd go up 9 over 2. And then if I could, I would go 15, up 15 over 2. And it's always from the previous point is to where you go up. From the previous point is to where you go up. Okay. So that's a graph of this time. Okay, one more, and then we'll bring this to a close here. So y equals, I'll say 2, and in parentheses I'll have 1/3 times of x minus 5, and then squared, I'll say minus 8. So my vertex is going to be at the point 5 comma -8. Okay, the vertical is stretched by a factor of 2. So the up, the 135 is going to be multiplied by 2. And the over every time is going to be the reciprocal of b. Remember, this is b. Reciprocal of that is going to be 3. So your over every time is going to be 3. So you're going to, from there, so if you look at it, so you put your points, you're going to go 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is 10. So I would go up 2 and over 3. And then I would go up 6 and over 3. And I can't go anymore. And I do the same thing going to the I can connect my dots to write my equation. Okay, so that is how you graph a quadratic function. The only difference is if the a value is negative, so if this guy is negative, then all that does to the graph is make the graph dip down. Other than that, that is the gist of how to